I would like to invite our first guest speaker to the front. Ladies and gentlemen, please give Mr. Peter Terbrugge from SRK Consulting a round of applause. Peter will be talking about pits, pits, and more pits.
Is this the...
That's the pointer. And
that's pointer and forward, which is forward, that one, forward.
That's forward.
Okay, thanks. Thanks for watching. Morning, everybody. Just before I start, I'd just like to say thank you very much to Reutech for inviting us to come down to Stellenbosch. Getting close to retirement, we've been living in Johannesburg for the last 40 years in one house. And my wife's been talking about Stellenbosch. And I said, no, geez, the wind blows in Stellenbosch. She said, no, it doesn't. So when I saw this morning, I told her, look, the wind's bloody blowing. Can't live in this wind. But it's a very nice place, and thank you very much for having us. Just before I start, I saw Jan at the Vancouver Slope Conference, whenever it was, years ago, and he was manning the radar outside because it was too big to go into the venue. And I said to Jan, can you tell me about this radar? He said, yeah. He said, it's come out of the Navy from the military. And he said, if you have a ship in the rough sea, can I use Jan's accent? if you have a ship in the rough sea and the radar is working and the radar picks up an exocet from 400 meters, he said he sends a signal to the gun and the gun targets the exocet and it takes it out. I said, oh, that sounds quite good. He said, do you want to buy one? I said, yeah, I'll have 4. I've got 4. Okay. Just in case you guys think that consulting is a bed of roses, it's not quite the case. I was doing a job in Angola, up in the northeast corner of Angola, and we fly to Luanda on the Sunday afternoon, spend the night, and then go to a place called Serimo. And then from there, it was about a 6-hour drive to the mine. It was only about 100 k's, but that was the state of the road. That's how long it took. On the way back, the camp manager got us up at about 3 o'clock in the morning to leave at 3:45. And it was a little bit better that time coming back. So we get to the airport. It's one of those new Chinese airports, all chrome and glass and plastic. And we started checking in at about, I guess, 9:30, 10 o'clock. And after about half of us had checked in, a guy appeared. He looked official and he calls for our attention. And he shouts out, the flight, she is cancelled today. One of our blokes says, well, this is Saturday morning now. I said, well, when's the next one? It's Tuesday. So we said, where can we stay in Serimo? He says, no, there's no accommodation in Serimo. So I said to our driver, I said, I'm not driving back to the mine staying there for another 3 days, because I had a bed in a tent that had a dip angle of 10 degrees on it. And after a few beers at night, I rolled out a few times. Anyway, our driver said, look, we've got to get back to Luanda today. He said, sometimes the militaire, they fly on a Saturday afternoon. And I said, well, where's that? No, just on the other side of the airport. So he drove us around there, and there was this plane, Antonov. And it's a cargo plane. And it looked to us like the whole of Angola was trying to get to Luanda that afternoon. Anyway, I think that the whole of Angola got on that plane for nothing, but it cost myself and my 3 colleagues $50 each, which went to some soldier. Anyway, we eventually managed to get onto this thing, and I don't know how well you can see that, but that was the inside of the plane. It was chock-a-block. There were no seats. People were sitting on their suitcases on the floor. Babies were screaming. People were being. It was about 55 degrees C inside that plane that Saturday afternoon. 3 o'clock in Angola, northeast corner. You can imagine how hot that is. And this picture will show you the distress that I was in. That's not beer spilt on my shirt. It's beer leaking out of me. Anyway, and when I got there and I saw this chaos, I thought this has got to be the worst decision I've ever made in my life. Anyway, we took off and we flew safely, and we landed in Luanda, and we taxied into the military base, got out, and then told us just a short walk to the gate. Well, the short walk was about 3 kilometers. Now 4 o'clock in Luanda on the Saturday afternoon. It was about 60 degrees. We got to the gate, and there was a guard there, and it was locked. He said he doesn't have a key. So he then said we have to walk to the terminal, which is about another 3 k's. Anyway, we got home and we arrived safely. So that's just my little story about don't think that consulting is a bed of roses. Right. This was a job we did at a mine in South Africa. It was a nickel mine. And we asked, we were in touch with a contractor in Nelspruit, just down that part of the world. And we said we needed a really hotshot rig to drill these holes that we wanted to do. He says he's got just the rig for you. And when we got to site, this is what we saw, this thing. It was dragged onto the drill site like that, just on those rims, no wheels on it. So they dragged it up there. And when they put it over the hole, we wanted to drill like 40 meter deep holes, and it could only manage about somewhere between 7 and 10. That was all we could do. So again, be careful about what you ask for. I thought I'd just take you through the history of that 2001 failure at Nchanga, where we lost 11 people. And sorry, it's quite a difficult thing for me to talk about, but I think you guys need to know about it, because it's something that can and will, if you're working in slope stability, affect us all. This is an early picture of Nchanga, 1980. This was the south face. South face was a very flat slope. It was only between 30 and 35 degrees, but it had a very weak rock in the footwall, as it were. It's a big syncline, so 30, 35 degrees there, and it came up, and this side was vertical. There were the two problem units in that footwall were what they call the banded sandstone upper and the banded sandstone lower, both aquifers, separated by a thin bed called the pink quartzite, which was a hard rock but very jointed. And we always had problems on this on this footwall, but because there was space at the top, and the pit was deep, the pit was over 400 meters deep, the failures on that slope never actually got to the bottom of the pit. So it was not anything that we really worried about. So that's a 1980 picture, and then you can see the failures actually starting to happen. Where's my pointer? Where's my pointer, Johan? Is it the button in the middle? Actually,
Yes, sorry.
Which one is this?
The small.
That one?
Yep.
Okay, right. Oh, there, I've got it. You can see the failure starting to develop here. Well, not starting to develop, I mean, that's developed. So this was the main ramp coming down. You can see it deteriorating down here as well. So that was sort of the history of the south wall of Nchanga. In 2001, just to set the scene, in November of 2000, Oscar, Stefan and I were asked to go up to the mine and do a risk review of the open pit. And on the Monday, we got up there on the Sunday. On the Monday morning, we had the meeting, and the first thing we asked for was, did they have an evacuation procedure in place for the mine in case of anything happened? Yes, they said they did. And we said, can we see it? They sent a young mining engineer off to get it. And we never saw the young mining engineer or the evacuation procedure at all. In 2001, it was April 2001, let's go here, sorry. The operation was taking place at the bottom of the pit here. And over here, this was the crest of the pit at that stage. There was a viewpoint here. And one of the managers had been down to the viewpoint to see, just keep an eye on what was happening at the bottom of the pit. And in the corner of the viewpoint, he saw some settlement and a few cracks around the back. And it was no big deal because that's what we saw all the time, and we managed it. Because there's lots of space over in this area here, and not a big deal. And the pit was that 255 meter bend, so close to 300 meters deep. And anything that happened here was never going to go to the bottom. Anyway, he reported it to the geotech engineer, who went out to have a look. Again, he thought no problem here. And then he went out on the Saturday morning to have a look, and there were cracks. And the cracks were tens of meters long, and there was displacement of 300 to 500 millimeters horizontally and also vertically. Again, not a problem for us. We knew it was going to fail, but it was never going to reach the bottom, and it was an issue because there were people working down there. That's where the main mining was taking place. Anyway, he went out on Sunday morning, and the cracks were hundreds of meters long. You can see from there to there is 400 meters. That's how big the cracking was, and it was bad cracking. Anyway, the geotech guy, he took the decision to radio the control tower and sound the siren for the evacuation, which he did. He then walked from where he was to his bucky, which was over here somewhere. He then had to drive along the crest to over here somewhere to pick up the ramp to come back down into the pit. And as he was driving down the ramp to make sure that everything that was supposed to be happening was happening, this thing failed. 5 million tons came out of this part of the crest of the pit here and roared straight to the bottom, hit this wall and turned left. And it took out 3 P&H 2300 shovels, 4 big electric drills, and a number of trucks and small equipment, a grader, Land Rovers, and all those sorts of things, with 11 people. I got a call from one of the geologist's wives from Vancouver at about 2 o'clock on the Monday morning to tell me about what had happened, and they'd asked Oscar and myself to go up there, which we did. We went up, and we were confronted by this. You can see the failure hasn't gone back very far there. That was a perimeter road, took that out, but this whole area was cracked from there all the way through to there, and that was 400 meters. This is a township over here. This is a low-lying area, Dambo, which always collected water. If I could just go back to my plan. In the early days of the pit, there's an Nchanga stream runs through here, and then used to cross the pit here, and very early in the pit's development, a lot of water was made in this area. So they diverted the river. They put a tunnel from here all the way around this end of the pit, and the outfall was here and back into the channel, and off it went. There was a gooseneck over here that they used for filling the trucks up for dust suppression, which ran 24/7. A great big pipe, water just like the bloody Zambezi River, 24/7. And then there was a high-level sump in this area, and the water, and because it's a syncline, it was dipping to the west. The water would flow down those 2 aquifers, BSS Upper, BSSU, and the BSSL. It was always wet. And that, at the end of the day, was the cause of what had happened. And now I'll just show you some of the carnage from this bloody thing. Sorry. Right. That is what remains of a 2300 P&H shovel. And there's another one buried in here somewhere. There's one of the drills. That drill was salvaged, but there are other drills here lying on their side. And there's a load of other equipment in here and people. We had an idea of where the people were. We were able just to compile a little hand-drawn sketch map of where they were. And we made a safe waiting place over here. And we had a big front end loader because they were worried now about starting to dig the stuff out at the bottom in case we reactivated the failure. Anyway, Bruce Murphy, who's now in our Vancouver office, and myself, we were put onto the failure surface. Let's go back. We were asked to go and walk around the failure surface with the prism on the stalk, and the surveyor was. We had pegs there, and he was monitoring where we were walking, and we were just trying to see if this thing was moving at all while the front end loader was loading out at the bottom, and it never moved actually, so it was fine. We in the first 10 days we got about the remains of about 8 people out, which is I don't know if you guys are involved in recoveries from accidents like this at all, both underground or in pits, but it's a very, very traumatic position to be in. I must tell you, you don't want to be there, and I hope it never happens to you. But it just makes every time I think of it, it brings home to me the designs that we do and the risks that we take, and often we're forced by GMs to give him another 5 degrees, because 5 degrees lower he can't make a profit, and you have to be strong to tell him you can't do it. And if he says bugger off, I'll get someone else, say thanks very much, I'm out of here. I don't listen to these people, because this is what can happen to you. And I'm not saying that this slope had stood for many years like that. We had small failures on it all the time, nothing quite as severe as this. Anyway, so that was the one I thought, sorry, not this, this is the one. There's a P&H shovel sitting there for you, totally destroyed. The claim for this accident was, in 2001, was $85 million. It took 7 years to finalize the claim. And the problem was, in the policy that had been drawn up in 1953, because that's about when the mining started here, there were two words that were used to describe a failure. One was collapse and one was failure. And the insurance people said whatever word was in the policy, and I can't remember which one it was, I think it was collapse and not failure. They said collapse is not a failure. And that took 7 years to sort out the difference between collapse and failure. Anyway, they were paid out eventually, but it was not a very pleasant thing. Oscar and Bruce Murphy were flying to London almost monthly, certainly for the first 2 years, to meet with the insurers in London. Again, also not a very, you know what lawyers are like, they're not great guys. They're nice guys, but they'll tell you black is white and make you believe it. That's what happened to the grader. A Land Rover, there were people in there. Okay, and that was it. We then, after that, it took us 6 weeks to get what was left of the last guy out, just as a matter of interest. And Oscar and I had only gone for the week to make sure that the operations were in place. And when we went to go and say goodbye to the GM, he said, "Are you both going?" I said, "Yeah, we both have to go back." He said, No, one of you has to stay. And when it was me and Oscar, I knew who would be staying. It was Jimmy. And came home 6 weeks later. So I had a very traumatic experience. We managed to rehab the pit. All that stuff was cleared away. We managed to reestablish the benches, and the mine continued. Mining back, this is where they were mining originally, and they went back in and they completed the cut without further incident. Okay, that was the very sad Nchanga story, and I just thought it was worth sharing it with you, because that's the consequence of mismanaging a slope. The water was a big issue. Every visit we had to the mine, we said, you've got to do something about the water. Nothing ever happened. No piezometers, no nothing. The pipeline that came from the outlet where I showed you, back to the mill, which was on the south face, that used to leak like a sieve. And when they were pumping the water just behind where that viewpoint was would shoot 20, 30 meters in the air and then just flood that Dambo area. So there was surface water there all the time. the aquifers. There was the high-level sump in the east end. There was the gooseneck. There was also a defunct sewage plant that sat on the crest, but also leaked water all the time. It wasn't working as a sewage plant anymore. So that whole slope was saturated. And nothing ever happened. And because after the failure, we got out all the reports, because I started working there in 1979 was my first visit to the mine, and I used to go up probably quarterly right through until about 3 or 4 years ago. All our reports, every last report that we wrote spoke about the water, and you had to do something about dewatering the slope, cutting off surface water, all those sort of things. Never happened. So perhaps we were never strong enough in telling them what to do. May well have been. Okay, now I want to show you some pictures through some very, very good open pits, and some pictures of some pits that had been very good pits, but all suffered some fairly serious failures. This was a pit in Australia, Cowal Mine, C-O-W-A-L. It had quite a thick cover of saprolite, about 30 to 40 meters and 50 meters in places, sitting on top of a hard dia-based type rock. And you can see the slopes in this rock here were quite good, as were the slopes in the saprolites themselves. It was quite flat. It was about 35 degrees. On the backside of this slope, there was a big lake. It was about 10 kilometers long and about 3 or 4 kilometers wide, but it was only about 1.5 meters deep. But they did nothing about trying to stop that water from getting into the pit. Sorry, I'll come back to Cowal shortly. This was a mine in Turkey. It was a gold mine. It was called Terbrugge. It was a fantastic mine. Sorry, I'm sorry. Sorry, let me go back there. Oh, this is Cowal as well. And the only problems that they had, some structural failures. You can see a wedge there, plain failure, a bit of a wedge, another wedge, and that was all. The crests were a problem to keep in place, but it was no big deal. There was nothing more ever than a bench scale failure. There's some more plain failures, no problem with those. This is Terbrugge. They had a fantastic drill and blast program on the pit perimeters. These floors were like these floors. You could walk on the floor with your eyes closed, no problem. And it made a massive difference to the productivity from the pit, as you can imagine. Trucks running up and down. The drills on the drill pattern, they just drill a straight line, turn around, straight line. Nothing ever stopped the operations in the pit because of the effort they put into making everything work. This is Kalgold near Mafeking. This is a very steep slope. It's close to 70 degrees with a very steep foliation, and we targeted the foliation on the benches, and we drilled our bench angles off at 70, and we got down to about here with no problem, and then we started to get some failures here. So we actually did we started putting anchors in, 20-meter anchors, 10-meter benches. They were 10 meters spaced 10 meters horizontally, and every bench between those two 10s, we put in one in the middle between those two, and we anchored that thing from that sort of mid slope height to the bottom. They're now pumping tailings into the pit from another mine that sits to the north, a pit that sits to just on the other side of the main road to the north, and that's being filled up with tailings now. This is there's the one in America. No, not Bingham. Is it Gold Strike? Anglo? Mike, do you remember the name of it? Okay, not serious. This is the infrastructure for underground mine in the area, and there was a portal underneath here as well. It was a pretty well monitored failure. It was caused by a big structure on this side and another structure on this side. So they knew all about it happening, and everybody was moved out certainly from the underground mining, which was happening below this slope at that time. But to re-establish what was happening at the bottom, and then to come and try and take this out, that became problematic. But they did manage to do it, and I think it still operates today. This is back to Nchanga again. Now, this is the north wall of Nchanga. In the north wall, there was a unit that we call the Chingola dolomite, and it was a very soft powder. And when you drilled it, it varied in thickness from about 10 to 40 meters. You got no core out of it, other than some chert boulders that came out. There were some hard cherty things. That was all, and it formed a big part of the design of that north face. This happened before I got there, so it was in the early 70s. But we did some underground exploration from what they call the 1500 drain drive east. We put development out at 120 meter intervals, because those were their section lines. So we put these the development out. We put a 50 meter vertical raise, and then an incline at about 30 degrees, and then a horizontal drive through this Chingola dolomite, which we had to shore up with boards, and then grout behind the boards to keep them open. And we were able to take samples out of that and get those tested. And we got the strength parameters we needed, and we didn't have any more incidents like this on that north wall. The north wall, well, we did have one or two, but not as serious as this one. Right, that worked. This was Anglo's mine at Sadiola in Mali. And the problem that we had here was the weathering profile in the saprolite was also quite a thick cover of saprolite. Again, it was 32 to 35 degree slope angles. But because the drilling was fairly sparse on that slope, the mine decided to steepen the slope before they got to where the rock mass actually became fairly decent. And you can see it's quite hard rock here. But above it, the saprolites are bad. And these slopes started to fail, and the main ramp into the pit came down that wall. And of course, it wiped out that ramp, and they had to put another ramp in on this side of the wall, this side of the pit. And then we lived with the problem of these bloody boulders, because the failure was now undercutting the slope, and this stuff was raveling in. And this is where it was a shear zone, and the shear zone was about 40 meters wide, dipping to the west. And so this was happening above the ore, so it made mining the ore out here very difficult. Anyway, they managed to do it, and they've moved on from there now. I'm just coming back to Carl Mine, that lake I told you about, and what they didn't do about trying to cut the water off. This is what happened. The slope became saturated, and I think it was probably saturated when it started, the mine actually. But this was the failure that took place there, and this took them about, I think it was 3 or 4 months to clean up and keep mining. So again, a water issue. I mean, water in slope stability is, I'm sure you all know, is our enemy, and you got to get that water out of those slopes as best you can. Otherwise, this is what can happen to you. This is one of our famous SRK vertical pits. This one is in Sierra Leone at Koidu, a town called Koidu, diamond mine. And there was a small quarry here. These are some of the benches of the quarry, but the owners now, they needed revenue to start their open pit mining. And they approached us and said, how can they get the kimberlite out without stripping any waste? We had done a vertical pit. The first one we did was at Nyala, which was a chrome mine in Zimbabwe, which was very successful. We got to about 90 meters, and the bottom of the chrome market fell out, and they just walked away from it. And that thing stood there for about another 2 or 3 years with a bit of deterioration. It was being supported, but the hole remained open. This one we mined down on the contact. So this was the granodiorite contact with the kimberlite, and we came down right on that contact as closely as we could. Support went in all the way down, long anchors at the top, getting shorter and shorter. The walls were shotcreted because and this was going to go to 110 meters. Again, we got to about 95 meters, and there was a big failure, which I'll show you next. But the walls had to be shotcreted and meshed and shotcreted again, because you can't have anything fist size coming off from up here reporting to the bottom is going to do some serious damage if you've got people there, or equipment even. Big issue. When we did the design, we said to the client that we want one of our young engineers on site to supervise the support installation. And it was shaft sinkers. I hope there's no one from shaft sinkers here. The shaft sinker said, we do this all the time. We don't need anybody to tell us how to do it. Well, this was the upshot of that. This was a wedge, which we had designed our support to prevent. Our anchors were long enough to go through these big planes to stop this thing happening. I again got a call that the night this happened to get on the plane and come up the next day, which I did. Let me just go back here. They strung a cable. They fixed it. It was in this wall here. They fixed a cable here, swung it and slung it across to this side, and we could get in the kibble. And it was one of those air-driven things, so we could go across, we could go sideways and up and down. And in these two planes that you see here, there was no sign of any anchors or any holes even. And when you get a failure like this, which you have supported, you will see anchors which hang out of the thing. Nothing. And in doing the sort of the root cause analysis, I guess, we think that they put in holes that were maybe 3 or 4 meters long and stuck a few cables out the collar, and that was it. Here's a scale for you. Here's a guy standing here. So say he's 2 meters. And this was at 95 meters deep now. This happened, came out with a blast. There's a big blast at the bottom here. Thank heavens there was nobody in the pit. Obviously everybody was evacuated. But this was pretty much the end of the vertical pit. They thought they could backfill the thing and then try and put more support in, but that was going to be too expensive, so they never did that. Anyway, off they went with that. So if anyone wants a vertical pit, we can help you. This was Freeport. This was not actually a slope failure, but it was a tailings dam that failed at the crest, which was quite close to the crest, and they lost 11 people here as well in this failure. Here are all the officials come to check up to see what's happened, all the nice fancy vehicles parked there, but it failed catastrophically, apparently no warning, and the operations were taking place down here. This is a pit in Chile. The name slips me again. But this was quite an interesting one because we had been doing some work there, and this was the main ramp into the pit, and that went right down to the bottom and turned around and came down in the bottom. And we'd been worried about this failure happening. It was a high risk area, and we'd been talking about force majeure to them. And force majeure was those two words were not something that they understood. And we said, if something happens to you now, this will close the mine. And in fact, it did. It closed the mine, and that was that. It reminds me of a job that Oscar and I did in Indonesia, a mine called Batu Hijau. There was an American guy doing the design there, and what his philosophy was, he would mine a bench. They were 15-meter benches, and if the bench looked okay, he'd pace off 5 meters and then start again. And that's how that was his design, literally. And he only did something when some cracks appeared. Then he'd step off 10 meters instead of 5 meters. So we said, you really can't continue like this. It was a circular pit, and we'd identified on the east side of the pit that there were some structures there that were unfavorable. But this guy said there's no problem, nothing worried him. And in a paper that we wrote and presented in San Francisco, we used that as one of our case histories, and we predicted a failure in that area. We'd also spoken to them because they also had a single ramp, only one ramp down. And if there are any mine planners here, and I know there are a few, beware of single ramp accesses to pits. If you have a failure, you've got a serious problem. And having spoken to them, from management down to the planning engineers, that if you fail that area, if it fails, you'll lose your ramp, you will have a force majeure situation. Anyway, they told us we can go home tomorrow. Off we went. And a year later, that's exactly what happened. That area failed, took out their ramp, and they had a force majeure situation. They were closed for 9 months. They were only able to operate from some low-grade stockpiles that they had. And you know what low-grade stockpiles do when you can't produce your high grades from the bottom of the pit. And they were very, very unhappy about that. And in fact, on that mine, just another sad story, there was a young hydrogeologist from Golder in Vancouver. He was installing piezometers. And on the last Friday that we were there, his name, I can't remember his name now, but he was putting the cables across the ramps, and they had those monster trucks. I mean, I think they were like 400-ton trucks, massive shovels and monster trucks. And at about 11 o'clock that morning, he came into the office to get some water, and Oscar said to him, "Are you sure you're okay?" He said, "No, he's got flagmen, he's got bollards out, everything's fine." Because they were digging trenches across the ramp, putting sand in and the cables, and then covering it up. Anyway, he picked up his water, he went back into the pit again, and about 12:30 we heard the siren went. And Oscar said to me, his name was Jamie, he said, "That's Jamie, promise you." And when we eventually, of course there was chaos on the mine, we eventually got someone to stop and tell us what had happened. It was Jamie. He'd been in the trench, and one of those big trucks, because you know those big trucks, and Dennis, you'll know, we as a driver sit way up above roof level here, and there's an area where you have no vision whatsoever. The truck went right over him in the trench. That was the end of him. We hadn't met the GM that week that we were on the mine, and then we stayed there for the afternoon trying to find someone to have our wrap-up with. We couldn't find anyone. They were all involved with this thing. We went back down off the mountain to where we were staying at this little hotel. It was called the Paradise Beach Hotel. It was on the beach. It was fantastic. And at about 8 o'clock, the manager came to us and said that the police are on the mine, and we were the last people that had seen Jamie in the office, and the police wanted to interview us. So we went back up and met the GM for the first time, apologized for not seeing us earlier. The cops interviewed us. There was no problem. We just told him what had happened, and back down we went. But again, if you're doing those sorts of installations in open pits, you really have to be very careful and make sure that your safety procedures are in place, and that you've got spotters, and that the operators know what you're doing. I mean, I had an incident on one of the iron ore mines in the Northern Cape, where I was mapping on a bench, and there was a dozer working on top, but he knew that I was there, and that I had my compass up against the joint, and the next thing, down came this bloody avalanche of iron ore. I managed to skedaddle and nothing hit me, but it was that close, so got to be careful. Right, this is Sunrise Dam, and this is where our good geotechnical friends thought they could steepen up the slope at the bottom to get some ore out that they wanted, and this happened. Damaged the ramp up here, as you can see, and it even went higher than that, as you can see here. It went all the way to the crest of the pit, taking out that ramp totally, plus some ramps that were coming from the top as well. And I can't remember if this was the end of, I think they continued to mine here and got out more ore, but it was a problem. Okay, that's pretty much the end of my pit story. but I just wanted to show you something else which I thought was quite interesting and hadn't seen before. This is Hong Kong. We went on a cruise and we stopped in Hong Kong for a few days, and we did a bit of traveling around Hong Kong. And Hong Kong is pretty much built on weathered granite, very soft, horrible type material. And if you design a slope in Hong Kong, your name goes on the slope. Dangerous hillside, retaining wall, pending upgrading works. This is the registration. And I think in the next shot, oh yeah. If you've designed the slope, this is your telephone number. And I think in Chinese, this is your name. So if something happens to your slope, you're going to get a call very quickly. You better know what it's all about. But interesting. And in fact, this brings me on to the new tailings dam document that's come out and what we have to do with tailings dams and the engineer of record. And I think that in terms of designing pit slopes, that we need an engineer of record to sign off on these things. Too many, I mean, look at all these failures I've shown you now. All have come about from, some of them, poor design. Others have become about of heavy rainfall and things like that, which you really can't do anything about. But if you're designing a slope in wherever, Colombia, for instance, you need to be aware that you get massive rainfall, massive rainstorms there, and that better come into your design. If you don't, those are the kind of problems you're going to have. This was just which was a fairly misty day, but that's what Hong Kong looks like from the top of the mountain. And you can imagine slope failure going down into that area there. It could be catastrophe. And then just to finish off with, this was the Hong Kong harbour, and the boats in there varied from things like this, and this was a small one actually, to this, and people live in those things. And the harbour is just there. It's where they do the ablutions. Everything goes into there. So I wouldn't recommend you go for a dip in that water. Yeah, and that's it. Thank you very much. Thanks for giving me your attention.